show. So I'll do JSON first. The JSON is going to use a JSON data type. And what I've done is I've basically just written a SQL script that's going to go through each of the steps so I don't have to cut and paste everything. And so what I've done is I mentioned the J purchase order table. So we've populated that in the column store. And I didn't have to do anything special because, and I have a describe here, which I think is, I should have done this in a different order. Crud. I didn't do a describe, sorry. So I'll do it in a second. So when I do a describe of the table, we actually have a JSON data type. So, well, we can just do this. I thought I put the describe for the table in the script and I didn't. So the table looks like we have a PO document and we have it defined as a JSON data type. So this is new in 21C. Prior to that, it might have been, say, a varchar or a clob, and we would have had a check constraint on it. But now you can actually store this as an actual JSON data type. So let me go back and restart this. And so what we've done is I just literally just an alter table in memory and populated the table. And this is a list of the columns. And so notice that since we have that JSON data type, we have, you can see as a virtual column, says IME. So that's kind of the IME is the trigger, and OSON obviously is another clue that what we have is an in-memory expression under the covers. And notice that we're referencing PO document, which is our column that is JSON. So hence the describe. And so we're going to return the data. Basically, we're going to query that virtual column when we do our JSON query. I get that right, Oro?
Yeah. Okay.
Sorry. So all I have is I'm just going to do a count star, so simplistic, but I'm looking for any purchase orders that have a zip code of 99236, which is basically San Francisco. And it turns out out of all of the data, which I didn't do I guess I didn't do a count star. We'll do that in a second. But 4,000 of those documents or purchase orders are in that zip code. So maybe we're doing some analytics on who is purchasing information or purchasing products based on region or something. I don't know, some query that you need. And so within JSON, that runs very, very fast. Oh, here we go. And so that, okay, I'll do the count. I'm out of, so there's two things I need to add to that script. The describe, which I thought I had in there, and then the count of how many rows or column values or documents are in our purchase order in the table itself. So I'll add that. We'll do a count in a second. So the takeaway here is that we ran that query. It ran in 0.03 of a second. We did a table access in memory full. And notice that in our predicate information, which I kind of was talking about for our where clause, we're showing that we're pushing down right there. Notice that we're accessing that in-memory expression, and Oracle's telling you that through the execution plan that it actually accessed. And I'm not going to try to decipher all this unless you want to spend the time on it, Oro. But the bottom line is you can kind of see this, and then with our session statistics, again, we see that we accessed in-memory expressions to look at that. And actually, there you go. So we have 10,000. I remember I took this example literally from the J purchase order orders demo schema, and it's 10,000 rows. That's what I loaded into the database. So out of the 10,000 rows, 4,283 of those, you can actually see that from this statistic here, passed our criteria, and that's what we returned for a count. We might have actually selected portions of the purchase order out of those values in order to do some work on them. But bottom line is fully supported JSON, rooting around in a JSON document in the column store, getting really fast performance.